Hello guys, welcome to part 4 of the series. Today we are going to be moving on from where we stopped previously in part 3, and basically we need to move a bit faster because we are trying to cover more grounds today. So I hope you guys learn as much and hope you guys are prepared for the journey ahead. So welcome once again, and let's get right into it. Right, so yes, time to start. Okay, sure you guys can see my screen, right? So I'm going to open my ID, get started, and okay, sure you guys can see. Okay, so we are open and time to get started. So yesterday, just to give a bit of perspective, what we did, let's see, go back to main RS. So we implemented the scene. The scene was the last thing we implemented yesterday. Before we rounded up part 3 yesterday, we talked about the scene, and that's the 3D scene. We built a 3D scene. We added some features, we changed some colors, and then we made it work as it was supposed to. So today again, we are going to be proceeding from where we stopped yesterday, and from what we said, we're going to do more on 3D rendering today and 3D scenes and some other important aspects of game dev and 3D rendering, or basically anything that has to do with rendering and in very intensive graphics processing today. So yeah, we said yesterday we're going to work with the 3D viewport tool, right? And I showed this example yesterday whereby we can load the shape or the 3D view, and then we have examples of the atmospheric fog also, which I wanted to show you guys yesterday. Unfortunately, it was not loading yesterday, but yeah, today it is, and you can see what the 3D view looks like. Now it's just a view whereby you can interact with. You can't really do much. You can't pan it, you can't scale it, you can't translate, you can't transform, you can't really do anything there. And you can see how simple it is to create once you just set up your once you set up the system, right? That's for the startup. You have the commands, the meshes material, just the typical thing we've been using for some time. Then we set up the plane, which in this case is our general view here. So we set up the plane, then the light, then the camera. So this here is the plane. Then we have the camera somewhere above or somewhere around there, right? Because we've already rendered it. So depending on the position we had it, it's going to be spawned there. And we say we said the camera was transformed XYZ 15 5 15. Looking at this, so we've already done that, and we spawned the light as well. So we can see that we've done all the setup necessary to proceed. And that's basically what this looks like. So if we have to implement something like this ourselves, can we do this? Because basically this shape is just, if you look at it now, of course this is a 3D plane, but what does it mean to be a 3D plane? It's just basically a shape as well, right? So let's try implementing this just to get a point of what we are trying to do. So the first thing is you can see this, how this zooms in and out, right? To give that depth that we're trying to talk about yesterday. So we talked about depth yesterday when we talked about the sprite animation and the sprite sheet, right? Not being able to implement depth for our two sprites. That's Gabe and Gabe, right? You guys remember Gabe, the sprite, the pixel guy we used yesterday for making the animations, right? For rendering the animations. So today we are looking at this, and you can see that there's a bit more depth. You can see this. It's as if we are pushing further into a space or a void, and that's basically what the 3D plane is. So we are going to render this. We are just going to write this. And so how do we do that? We are going to start by implementing this that we need. We're going to write this. I'm going to close this because we don't need this anymore. Of course, this is also important. So we could even write it on display now, since we already have our camera spawned. So what we are going to do is we're going to proceed from that where we stopped yesterday, and we're going to try writing this, right? We call it ground, basically. So because it's our plane. So because we want to create it as a ground, we are going to create a struct. and call that struct. We are going to create a component, right? And call the component. Let me go to 3D sync because that's where we want to add this. So we'll create a struct. In this case, um, let's derive our components, right? Basically, we derive our components and then we create a struct and call it ground. You can start to call it anything. It doesn't necessarily need to be ground, but we are sticking with what they called it here, ground. So what do we need to do next? We need to set up our plane. Now remember that we already set up this currently, but we also need to set up our plane. So that's what we need to do right now. So setting up the plane is quite easy to do here. We've already done something similar in terms of creating the mesh, right? So let's set up our plane, right? Let's spawn that. So we use the same commands dot spawn, then we spawn that. But in this case, we are going to be doing something different because we don't just want to spawn this. We want to create a mesh 3D. Let me close this. I want to create a mesh 3D because it's still a mesh, right? We already have our meshes implemented. So what we want to do in this case is to mesh dot add. We want to add what? In this case now we want to add the plane 3D, not a 2D in this case. And then we are creating a new plane. So we need to give it dimensions in this case. Okay, you're just creating a default in this case, so there's no even need for that. So we just create a default plane, no need for the new. So default mesh size 20 by 20. So we do the same thing for the next thing is to do implement the material. So I'm just going to copy the color since we know that they have a default color that's already specified. So then next thing is to why do we have multiple necessary brackets here? Okay, so let's add our ground to it because of course I want to reference that as ground. So basically that's what we're doing in this case. So we spawn all of this, right? The ground, the entities, basically they're just we spawn the components, we spawn the mesh 3D components, or in this case we spawn the mesh 3D, the material and the ground. So because we want to use that as a component, this ground will be defined here. So that means we can reference it within any of the systems. So now how do we do that? All we need to do is just go implement it here. First of all, we need to add that to be sure that it's already updated. So how do we draw that? We are, this is just the cursor. We don't really need this, right? Basically, if you just implement this again and run this or rerun this, because we don't want to implement the we don't need to implement this draw cursor implementation. The cursor is just this depth field that we get here. That's basically what it is. And what the cursor does is just create a gizmo and you use that to add some certain points to it. I mean, in terms of circles to it. We are not trying to do that. We're not really interested in doing that currently. So let me close this. I don't need to make things right. Okay, so creating my new window. Oh, why is it taking time to load my window? Now you guys can see this. You can see the plane, right? You can see the plane literally on it. And you can see that it is like being placed on top of the circle we defined before and making this float on it. So what people can do is just to change or define the dimensions to like transform it a bit. We can basically do that. Or we can transform the circular base itself by okay, this in this case there's no transformation for the base, but we can transform that. Let's just copy this. Um let's add a transformation to it. Transform from x y z. Let's do a -5 exactly. So it goes down, it goes underneath the circular base. Right? So let's run this and see what we have. Now, basically, you see that everything we are just doing is just like trying to add this, manipulate this, add this. Basically, that's the idea of what we are doing. Now you can see this. We have the plane, then we have the base, the circular base on top of it. Then we have that also. And you can see the shadows being casted on all of them. So you can literally see what we have here. But interestingly, you can see that this base is a bit, this one is defined, but this one actually covers the entire world, right? So it's just based on the way we defined everything. I mean, in terms of like positioning and stuff from beginning. If you notice what is done here, you can see the camera definition, you can see the light. The way we define that camera is actually different in this use case. But the idea I'm trying to point out, or what I'm trying to point out here, I I believe you guys understand, right? So you can see that what we have here is mine negative 0.5 for the y-axis, and you can see that already defined here. So that's basically what I wanted to show you guys for the plane. So that is how the 3D plane looks like. We are still going to make use of this, but currently, let's move forward. We are going to come back to it when we are dealing with actually building okay, so let me not spoil that now. We'll come back to that when we when we have to. So let's proceed to something else. The next thing we want to do in this case is the atmospheric fog, right? So I want us to see how that works. I think it's opened here. Yes, you can see this. Now remember the way we implemented the bloom the last time, right? For those that followed this tutorial till this point. Remember, we created something similar. We created something like this and called it, implemented the light source, right? And then added that softness, intensity, all of those things when we implemented the 2D bloom. Now, this is a bit different, right? But not too different, not too different, but it's a bit different. And the reason why this is different is because we are not just implementing a bloom now. We are this is actually more like a fog. Now, if you look at what from the name itself, you can already see that it has this 3D rendering slash atmospheric fog definition, right? And so that already means that, sorry, so that already means we have the rendering, we have the fog, and then we have something rendered on top of it. Now, let me press the space bar just to, you understand how to do this text, right? So you understand how that can be done. So if I press S now to toggle the directional light fog influence, I need to toggle this first. You can see pressing S changes the way it's set on this view, this canvas that looks like mountains, like green mountains of some sort. So you can use S to toggle it, and you can use this to toggle it completely. You can see. So how do we do this? How is this implemented? So first thing we need to see, there are two things we need here, right? There are two things we can understand from here. First thing is we have the models, which is the mountains. So we've not actually used models before till now, but we can actually try using it now. So what we need to do first of all is go download our model from the official GitHub repo. So let's look at the model terrain mountains. So like we did yesterday when we wanted to get this sprite, we can do the same thing here. We go to examples. If you are following this and trying to implement it the same way, go to examples. Next thing you need to go to, we are not using assets now, so you need to go to models. Where's our models? Okay, so let's see. We have the models from assets. Models. Yes, from asset folder, you go to models. From there, you go to terrain and you go to the mountains. You can see there are different mountains. Mountain being mountain GL, LTF, and GLB for terrain. So, but what we need is actually the mountains, right? We can download all of it because we definitely still need them. So, you just click on this. This is the model. This is what it looks like. You can see this is just it's just this. Let me refresh this. I don't know why GitHub keep breaking these days. It just breaks like this and then always like that. So weird. But yeah, basically this is what the model is. So we can copy this, literally copy this because it's just this definition, right? So you can see Chronos, GLTF, Blender, this. And then we can add it to our asset again, but we create this as not just directly into the asset folder. We add this as a terrain, right? We place it into the terrain directory. We'll call it terrain. And then inside the terrain directory, we add a new file and we call it mountain.tltf and mountain.tltf. We call it mountains. Yeah. So we do that and then we paste this. Yeah, we have our asset defined. So I'm going to close this. Then that means we can make use of the asset now, just like it was used here to spawn the terrain. Then we can see that there's also a sky. right? So literally you can see that this sky is just is literally defined. There's just a background color aside from the terrain and all of those things that are defined. So we don't really need to bother much about that, but you can just to give you an idea. Something we can just copy the colors and all of those things to make it work. And then if you click on the space bar again to bring out this directional light fog influence, you can remove the atmospheric fog. Then I can press S to toggle the fog itself. So what we want to do now is excuse me. So we'll do this. I'm thinking should we even implement all of this? I want us to implement something that we may need. Right. What I think is we might not need the terrain just yet. We might need it, but for now I want us to use it for something, not just implement it because we can see it here. Something like add other things to it, add more stuffs to our terrain. Right. I know that once we define this, we can add cubes, we can add shapes, we can add other things. But that's not just everything I'm trying to implement here, or we are trying to implement here. We're trying to do more. Right. So the first thing I want us to do is set up terrain scene. Yeah. Then we build this with the sun. Now the sun is what's okay. Basically, let's look at it from here. Toggling the fog, we already understand this, so I'm not going to talk about that much. The settings, we already understand how that works. Why is this so lively? What's wrong with my system today? Why you like it? We already have space. So what's that? There's a lot of things wrong with the configuration. Okay, so literally we have all of this. Yeah, I think we should be better. So let me just try explaining the code. We have the sun, as you can see. In the setup, we have the sun, right? We have the cascade shadow config first of all, because um you know what? Let's skip this. I don't really want to talk about this because I want us to use it for something else, like I said. Let's go to another example that we can actually implement for real life scenarios. Right? There are other things we can use here, like the 3D bloom is an example, but I don't want to talk about that. The sub camera view is important because you can use this to implement different view effects. So view effect on the camera. You know, a camera in this case is the reason why we keep defining cameras, if you've ever wondered why, is because the camera is more like how you look into the world. If you pick your phone right now, right, you use your phone to view, just even though your eye can see, right, but you still need your phone right now to be able to capture all of those things. That's the same thing the camera does. Your mobile phone camera does similar things. It behaves the same way as the camera we are defining here. But what we do here is when we define the camera, we are actually opening a portal, let me call it that, to a virtual world that we are trying to create. So without the camera, we can't really see anything in the world, right? We assume that it's virtual, so we can't see it. It's more like a virtual, it's more like all this augmented reality, VR kind of thing. You cannot see, you know, there's a world built, but there's a way you have to view it. There's a way you need to enter into the world. You enter into that through the camera. The camera is more like what is recording what is happening in the world and playing it to you. That's basically what the camera is. So you need a camera to record what is happening there because you are physical, you are interacting with the virtual world, but you need a camera to actually interact with that world. So the camera is what records what is going on in the world, and you are simply interacting with the camera to see what is happening. So everything you see on screen, every single time you make this render, like the 3D shapes, the 3D circular base, and even the 3D plane that we see here, we can only see them because the camera we defined is positioned in a certain way, and that's why you see that it's very up close, different from the example we tried because our camera is closer to this element than the example they implemented. So the way you position the camera gives you the viewport of what you can see in the world. We are still going to come to a part whereby you can rotate the camera to rotate the elements to be able to see the 3D components, their different size and all of those things. The reason why that is possible is because then you're actually rotating and interacting with the camera directly. You are not moving the camera from side to side and you are seeing different things. That's the difference. Don't worry, we are still coming to all of this. I'm just trying to explain so that it doesn't feel too vague when I'm showing all of these examples because this is 3D, and 3D you think more about how things work in the real world more than how it can be done abstractly. You have to like relate most of it to the real world scenarios. and then it makes sense. Now, looking at this example, I want us to look at this example of light maps because this is another very good example of fog. This one, the distance fog effect, but these are just effects. We can always come back to pick them when we need them, right? This is a custom mesh where we can generate a custom mesh and even toggle how it works and move it around. But we are not doing all of these things yet. So let's look at lighting, some light maps. Let's start with this. The light map. Resin is seen with baked light maps. The reason why we need this particular implementation is because it is important for our use case going forward. The reason is because whatever you interact with, you need light. If there's a camera, even if your phone is there, you need light to be able to see some certain places. If there's no light there, you can't see anything. That's basically the way it is. We need light to for our camera to be able to function properly. Like I said, you need to model all your 3D implementations like the real world. If you do not do that, it's going to be a bit tricky for you to understand what happens there. So we need to understand that very, very much. So now going back to light maps, now we can see this, right? You can see that it looks a bit different from what we saw initially when it was rendered. And later on, it just became exactly what we saw here, right? That it was loading everything into view little by little. But as you can see here, these are just shapes. Basically, if you think about it, this is just a shape. Remember the diagram I showed yesterday of this? This is basically what is happening here in the map. This is a 3D kind of cuboid that gives you a perspective of something going that has a depth. In this case, that has a depth of something like this background. If I do not turn this by the or rotate this by the z axis in this case, and I just position it directly to be straight facing me, I'm going to see this kind of shape there. And then this is just a light source. There's no light here actually. You can now begin to see how all these games are being implemented, where you see lights flickering or you see lights casting on the user or the players, the passes, and all of those things. Now you can begin to see that this is actually similar. It's not too crazy. It's not out of place. It's not extremely difficult. But then before we say it's not extremely difficult, let's see what it entails, right? Because we've not done something like this. Of course, we can create cuboid now. We can create cube and cuboid, yes, but we can also create shapes. But then how do we implement all of this together? We can see different shadows. We can implement shadows already. You can see the light source casting on it. You can see the red casting on this. You can see the green casting on this. You can see the light here casting a shadow on all of this. And the light here reflecting here, light here reflecting here, giving them different tones. You can see the shadows on this place. How do we do all of this? Right? Now, the first thing is we are using an asset here in this case. The asset we are using also, we need to go and let's get the asset so we can be sure we have everything. Let's go to kernel box. So I want to download the GLB. So I'm going to download this kernel box. I'm going to just download it to my downloads file, and then I'm going to pick it from there. So I'm going to add this to kernel box. I'm going to create a directory called kernel box. If I'm not mistaken, let's try using the actual name. Yeah, let's use the underscore. I prefer using that when I'm working with Rust. So let's call this kernel box.glb. And yeah, so let's do this. So it's going to create a directory, place that into it. You can see the GLB here. And then if you view the raw form here, just to give you a perspective of what it looks like. Yeah, that is it. It's going to just cost you to download it. So basically, we are looking at the GLB, whatever that is, right? And then you can see, I don't want to open that step. So we are going to use that first off. Now, if you understand what is happening, you also understand what's happening here. Let's read through the code. The first thing we understand is from setup. Let's go to setup, right? We always want to spawn the camera first and create the scene and all of those things. But in this case, you can see something different happening here. We have something called the scene root. For the first time, we are implementing something entirely different. We are not implementing a camera as the first thing we define, right? But we still created that also. You can see there's still camera 3D default and transformation happening here. Yeah, perfectly okay. Yes, understood. But that is not that we are seeing something entirely new called the scene root. Right. So now if you look at this kernel box here is basically this box you can see here. So yeah. So let's go back to this and then show you guys this. Let's actually create this. Then we took it like we always do so we can see how the pieces connect one to another. So creating the light maps. Let's call this light map. Let's create a new file. call it light maps. Yeah, add it to module, don't add it to git. So let's copy this, let's add this to it. Let's copy this. So there's an unused, there's an, we don't have this, so we need to add these dependencies first of all. That's why you see the errors there. So then we need to cargo run to install that. Okay, I'm just going to wait till I need to do that. So if you check the cargo summary, you can see that we have this here, right? And you can see that cargo build will automatically install the argh arg. So we need to also copy our main function. Nope. So copy the main function and add it to this. And then we need to add our functions, our system functions, define all our system functions. Now I'm just copying it one by one. The reason is because I don't want to like copy it once through actually. I wanted to take another approach, but then let's just copy everything, then we break it down, then we continue and check everything one by one. So there now we have our installed, right? That's done. Now let's try writing this. But before then, let's go back to this. Add our main to be public so it's accessible outside of this file, inside of this place. Let's do this. Light maps. Yeah. So we don't need all the sprites, we don't need all the postage on it. So we just need to render this, stop and rerun this. So let's see if we have the same thing. First thing we're going to see is going to throw an error. Yeah. You can understand where the error is coming from. The error is because we do not have exactly the same path for the model, so nothing gets rendered, you can see. So that's the first thing we note. So that means our models does not do the same thing. We only need the kernel box. So we are going to use the name we use, kernel underscore box, kernel underscore box. Now we run this to see if it loads, yes or no. So everything should be working fine now, and then we should see the same thing. But there's a problem, right? You can see the way you render. Remember when you first loaded the page, this was the same thing we saw. Then we now saw it added some other things like all of the shadows and all of these things. Now you can see the difference. The reason is because there are some missing files from the GLB itself. That means the GLB is using some other interesting things that we do not have here currently. So that means I need to get them from this place also. The reason I'm showing this is because when you work with all of these things, most of the things you see are models, right? They're just models that you can use consistently. You don't need to create shapes every time. They are already created using all these programs, like all these 3D rendering programs. And what you just need to do is import them. They support most of the engine support, whether using Bevy or any other engine. They support using the model, importing them and using them directly. But first of all, let's get the light maps and then we can use that to see. So we are going to go to light maps and download these two. Download the kernel box, large, small, mixed lighting example, all of these things. So let's download these two. So we can't see the view raw, right? You can see it's just going to ask me to download it. So I'm going to download it to I'm going to download it to my downloads folder. I'm going to download the large also because there are three things it's missing. It's missing the large, box, and small. So we need the three of them: large, box, and small. So I'm going to download this as well. Then the small also. Then if I check this, I'm going to see the same thing. You can see the KTX2. So basically, let's add this now before we move to the next thing. I'm going to add the three files we just downloaded, small, large, and light maps. I'm going to add it into our kernel box. I'm going to, yes, just add it to kernel box. And I'm going to change their names. First thing first, change this to, yeah, no, you know what, there's no need. The reason why this is a bit tricky until we need to change, probably open in, no, you know what, let me open this, the text file. Oh no, wrong encoding, wrong encoding. Jeez. I hope I've not corrupted the file. All right, so oh no. I'm trying to do that. I don't know the file type, so I'm just going to leave it as not known. Auto detect by content. Oh yes, GFV viewer. So let's see if this works. Hopefully it works. Then we can see it as the 3D model, right? So the reason why I wanted to open that is it could open like this because you can see it has a JSON different definition as well. And then probably if you can do that, we can change the path that it uses because currently using the path asset light mapped corner box, but we don't have the path light maps here. We can actually do that to make it life easy for us though. That's one way. I was just trying to see if I could make changes to them. So right now, if we let's see, the JLB viewer is still installing, so I'm going to just assume we don't need to bother about that. So let's try rerunning this and see what we have. So if I rerun this, it's still going to render here, but still missing this Bevy assets, light maps, kernel small. Why are the names different? Oh, I forgot this. When I downloaded it, the name was changed. Dash small. ZSTD. Did I just download the wrong thing? I think I did download the wrong thing. No, I downloaded the wrong thing. There's no large. There's no box rather. Connect box. I already downloaded box, and there's box there. Did it just change the name for me? Okay, this is still downloading. Wow, it's quite heavy. There's literally a plugin for everything. That's cool. Yeah, and now we have the same thing. Now, the reason why we have the same thing, you understand, is basically the imports. We imported all of those things. They are not what we have. They are not what we created. They are just assets, as you can see now. They are basically assets. So without them, everything displays terribly without those things. But now that we have them, you can see what we have. It looks cool. But remember, these are just models that we copied from somewhere and we are using it. So this basically is the world of most games. They are just models that are imported, created somewhere, imported, and used as the real world. They are not things you have to manually do like we've been doing. The only reason why we are doing this is because you want to see them in action. Right. So does that make a bit more sense? So that is one of the examples. So using this light map, let's try tweaking this to see some of the things that might change when we do that. So the first thing we see here is add light maps to meshes, right? You can see we have this. We can change this part to okay, no what, let's leave it. I want it to be in different assets. So this is what was loading and that was what filled. And you can see that this is to define the exposure, to add the light maps. So we get different light maps. We get the large, we get the small, we get the box, right? And we are simply just inserting it into our entity here by using commands.entity. So we're not really doing anything different or anything that crazy. What we are simply doing is we are picking all of this by running through a loop of all the meshes, right? And add each of these light source to our entities. And then if you look at the results, truly, the result contains all of the reflections, the shadows, and all on top of on all the objects we have, all the entities that we have, the objects, the entities, the shapes. You can see it perfectly aligned with them. And you guys can see the mistake first of all. Once we didn't have the light sources, it displayed without being refined like this. It just showed us a bland form of display. But now that we added all the light source, we can see how the light changes it. So it gives meaning to what I was talking about light the other time. You need light to be able to display what you want. Now, currently, this is just something I want us to see so we can understand. So what I'm going to do is I'm going to restart the plugin, right? And then so that we can see and open and see the model in action. I think that makes more sense. Okay, so we're going to go back to run this. Now that we have this, we can check the GLB, right? Did you just freeze my laptop? I hope not. Oh no. Just freeze my ID. This is a bad decision installing this. Let's quit this. It actually feels responsive. Then why didn't it work? That's so weird. Oh my god. I've not been sharing my screen since. Thought I was doing that. Oh no. Oh, I'm so sorry, guys. Jeez. Sorry about that. I thought I was really sharing my screen. So I've just been talking without sharing my screen. Oh my god. Oh jeez. Oh no. All right, so now we're back. Let me just show you or redisplay what I was trying to show the other time. Let's look at the plugin first to see what we can use to load. So I installed the plugin. What I was doing first was to install a plugin to be able to see our GLB. Right, our GLB is just a model we downloaded from Bevy to be able to use some of their assets to load what we had. So GLB, if you want. I wasn't even aware that it was not being displayed. I thought I shared my screen, or maybe I did and it disconnected. Oh, same thing. Okay, we literally just experienced this. So I'm going to just disable it just to prevent us having issues. Apply this, open this. I'm going to restart again just to get that out of the way. So I'll just assume we can open our GLB file now, and then we're just going to proceed. But let me just run what I did just now for you guys to see again. So I'm going to rerun the main file so you can see what we did while I was not sharing my screen. So this is what we rendered. And this screen, this view we rendered is basically what is coming from Bevy. Right? Bevy created something like this. All they did was just to, from the examples, all they did was just to load some of the assets and make use of them to generate this. So all of these are assets. All of these light sources you see, they are light maps, right? Or assets that I got from the repo and used it, and just like that I got the same thing basically. And how did they do that? You can see all they did was just to add the asset basically used by qubit sampling. Remember the sampling I was talking about yesterday, right? This is example of those things. So if you remember that discussion where we talked about sampling and talk about why image processing needs it, exactly this is what is happening. So you can see all of those things as well. So this is how this was basically implemented, and that's what we have now. So back to another example, right? Because like I said, we need to work on some 3D elements today. This is also another interesting example to work with the lighting, right? And then there's a way to also load GLTF, renders a file like it as a scene. We can also render a file as a scene. We can do orthographic view. We can implement motion blur, demonstrate pixel per pixel blur. Now, this one is quite interesting. But another thing that is interesting here is physical based rendering. You can see the way this changes. It looks like a bit more metallic to a bit more rough. Like, so we're going to look at all of this too. So let's check the motion blur. This is a very interesting one. So now, understanding this example, if you can look at it, read it, understand what is happening by just looking at the code, then that means you've already got into a point where, yes, you are comfortable with working with Rust and working with Bevy. Even if you have not gotten to that point yet, yes, we still have more things to learn. So yes, you've grown at least to understand some other things. Like I said, it's beginner friendly, so I'm appealing to both people that are starting afresh, people that already have the knowledge. So looking at this example, now we can see this. It says if I press the space bar on this, cycle the camera, if I press 1 or 2, it doesn't seem to work. Okay, nothing seems to work yet. Probably still loading some of the things because it's a lot. You can see everything we have here because it's a lot of things. Looking at this, you can see spawning different things. All of these are not placed custom. It's mainly just a calculation to define where to place it on the scene. As you can see, let me show you where it is. They are cars. Where are the cars? Okay, these are used as cars, these shapes. And these are used as what? Let's see what they define them as. Um, let's see if they are barriers. Yeah, let's call them barriers. So the barriers have been spawned multiple times. How do we know that? Let's look. There's a spawn function here. I can see that already. Spawn barriers. And what that is basically a loop to be able to display somewhere. And how am I sure? If you look at spawn barriers, you can see after implementing the meshes, materials, and command, right? Next thing you see here is we created a mesh from this, added some capsule to it. Capsule in the sense that we have this thing that looks like this rounded kind of, right? And then they transformed it a bit. Let's look at the transformation that was done on it. So it was transformed. The capsule was defined. We implemented the material on it first of all, added the reflectance, right? So it reflects, and then spawn with offset. Implement that spawn with offset. Now this is where the loop starts. And the loop starts by tracking the position of all the offsets, right, and spawning it at different intervals, different positions. You can see post.x and post.y. So it was spawned at different places. And that's why you can see it. So it's not as if it was written one by one. Another thing you can see here is you can see the spawn for trees. So that means the tree was also spawned, the cars was also spawned. You can see all these trees, these are the trees. So all of these are the way you spawn things mostly on all this game that we see and all these words. All they do is basically the same thing as we can understand here. So yeah, the example doesn't seem to work. I can't seem to like make any change here. So I can't cycle the camera. Okay, let's go to another example just to see for reference purposes. Okay, it doesn't work. I was thinking maybe I was all right. Now let's I really like us to look at the parenting attributes, whereby you can define parent-child relationships and relative transformations. But then I think we already covered something similar to it initially, so we won't dwell more on that for now. Let's look at the physical-based rendering first of all to understand what is happening here. In the physical-based rendering, so let it just load before I explain what I want to say. But basically, what we've seen so far on physical-based rendering is just the way it renders this from like looking like a more physical object, right? And in this case now, we define a 3D scene first of all, because now we're working with 3D scene. Define a mesh, multiple meshes by implementing them in a loop. And we proceed, we proceed, we proceed. We add the environment and all of this. I'm just waiting for it to load before I show you what I want to. Now, while we are doing that, let's look for another example first and then try to move from there again. This is a complex scene, but it makes sense and it works. Physical based rendering, why is it not showing? Okay, I can't seem to get this to load now. So if this doesn't load, we're just going to go to some another aspect entirely. And what we are going to talk about now is like based on this, we've checked the different categories. We've checked the 2D rendering, the 3D rendering. Let's go to animation a bit. We've done animation here, but the animation we worked on was 2D animation. That was the Gabe guy we worked on. We can also implement animated transformation too, but we've done a bit of transformation on the 2D world. In fact, a lot of them, right? Not even some. We did animation on the objects we created on day 2. That's in the second part of the series. We implemented transformations of translation and animation on that day. Okay, this is refusing to load. So so all of these are basically animations. But there's one cool one I want you to see here. I want us to see from here, which is animation graph. Now the animation graph does something entirely different, something simple and a bit different. It allows us to animate a 3D model, just the same way we did a 2D model. That was the way we modified the Gabe and the animated Gabe. That's the sprite we did the last time. Now this allows us to animate a 3D model. Now it looks like the code is a bit much and complex here. But it's actually not that crazy. You can see that the first thing we see here is what the fox is animated. Animated fox is loaded as a model, right? You had the clip of the first one. You had a clip of this similar thing, but you see that you are defining the animation 0, 1, 2 here. If asked to save, do so, all of these things. I really want us to see this so that we can understand the scope of what is possible by working with this. All right, all of these are refusing to load. Definitely not my network, I'm sure. Why is it taking this much time? So we can also work with audio, right? These are different audio things we can work with. There's also this, we can implement a 2D screen shake to shake the camera. Remember that camera implementation I talked about, that you can move the camera around at the beginning of today's video, that we can move the camera and we can see the world in 3D also. Now that is also possible. This is also possible here in a 2D top-down camera. A 2D top-down camera smoothly following player movement. So we can implement something like that. Let's see how it looks like. Hopefully this loads. About 2-3 of them have refused to load so far. Why? What's happening here? Come on. Just refusing to load any of this. Oh no. Okay, this is not going as well as I planned it. What is happening? Bevy network, which of you is misbehaving now? To be sure. It's my network. Sure, I'm well connected. Doesn't seem to lag. Oh wow. It's really struggling to load the web GPU version. Okay, so this is what we are trying to do. In this case, you can track the light by using the camera, by using our direction and our keys, right? You can see can track the light here, you can move the light, and you can see as you move the light, the camera also moves with the world. It's more like this is a user that moves, and as he's moving, but in this case, he's holding a torch, let's assume. And as he's moving, you can see the light reflecting around the environment, just as you would in a typical world, right? This is exactly another thing. So the camera will smoothly track the light. So in this case now, this is a form of tracking, where we are tracking, and you can see that it's not that difficult to implement. So aside from the move player, which is just a simple key code implementation, right, to determine the movement of the player, the important thing here is the scene, the setup scene, not the setup instruction. The setup instruction is just for the text, basically, and then you set up the camera, and then you update the camera. Now, all of these are done. The update camera is mainly the where the actual work is done, but it's actually not that difficult, because if you think about it here, we have just the player, which is a transformation of which you load the transformation with the player, but without the camera 2D, and then we translated the camera in this case. Remember I said we can move the camera as well. That's basically what is happening here. But for us to move the camera, we need to know the direction we are moving in. So we need to define a vector 3 to know the position of the camera, X, Y, and Z. And then we also need to define our vector 3D in this way to get an X and Y. And so we define that to smooth nudge by translating it very smoothly. That's basically what we are doing here. Then moving the player is just a way of moving the direction X, Y, X, Y, Z, X, Y, Z. Basically in this form is X, Y, since we are working with 2D, there's no Z, right? So that's basically why we have X and Y. So that is that. In this case, let's check the animation. I wanted to show you, yeah, this is it. So it finally loaded. Now, this is the animation graph I wanted to show you guys. In this case, I think it's the other one I want to show. Now, in this case, this doesn't do anything, right? It's a click and drag an animation clip node to change its weight. So, but this doesn't work. It doesn't work. I think I've tried this before. It doesn't do anything. An animation clip. Nothing clicks here, so it doesn't work. So what we need to do is go back to the other one. Let me show you guys the other form of this, which is the animation. Let's go back to the animation and show you the animation mask. Now the animation mask here will give you a sense of how animating a 3D model looks like or feels like. Now hopefully this loads faster than the animation graph, since you're not working with this one anymore. Why does this load now? Volumetric fog. Now this is a bit of work. This is a lot, because it requires certain assets, certain models to be able to create. So, and that's why you see we have to import like 2-3 models, if I'm not mistaken. It doesn't even show for me to like read through it right now. But finally this one loads. So you can see this. You can see the metallic sense in terms of lighting and light source. You can see the way the light shines on it as if it's actually getting from somewhere. So that is exactly what we are trying to talk about in terms of the physical rendering, physical based rendering. Now in the physical based rendering here, you are simply rendering an object or a mesh that you create, right? You are rendering the mesh and making it look a lot more like a physical, like a physical representation of that object. So in this case, the major thing that was done here, let me just use that word, is not in the setup. The setup just creates all the meshes by making multiple meshes and adding. There's this thing I want to show you now. Now, when you create the mesh 3D, you can create a standard material. You can add a base color to it. You can add varying metallic colors and roughness, and that is why you can see that from the top here it has a lot more metallic property, and as it goes down to this place it becomes very rough right down here. And so that just show you a progression of how it works. Now this looks more like a metallic thing. This they are varying metallic objects, right? This looks a bit more like a smooth marble. Now you see the processing. Now it gets clearer. You can see that it renders to something as if it's really reflecting on an actual thing. You can see how it renders. So it was taking this time to render because this is an heavy rendering. And you can see it took a bit of time, but it did render. So this is the metallic and this is the perceptual roughness defined. But you can see that this looks extremely clear. And the light source is coming from where, and it also has a reflection, which you can clearly see what is inside of it. If I zoom in this screen, you can clearly see what is inside this. It looks like being in an alley, right? And but as you move to the right, it becomes less clear because the roughness begins to set in. Right, but you can see this is very clear. It looks like a clear crystal, polished, well polished here. So that is basically what we are trying to show here. This. So this is a lot of this takes a lot of time to render. And that's why you saw that it didn't just come up once. But then remember, we also needed to load this for the map light, and that's why you can see most of those things you saw there, because that's basically what it can see right now, because it's just a reflection of light back to we that we are seeing it from the camera now. I hope that makes a lot more sense. I'm going to close this because it takes a lot of resource to render. Now, okay, yeah. So this is working. So let me show you guys this model to see how it works. Now, this just give you a bit of perspective. Now, if you have to read this code, yes, we can understand. But the first thing I want us to see here is you can see different things. You can see that there is hip, spine, neck, head, just for the head itself, right? For the front leg, we have the root directory, the root joint directory, B root directory, hip O1, B spine O2, B spine O3, B left upper arm O9, B left forearm 10. That's for the left front leg. Left front leg is this one, right? Oh, this one rather. Yes, that's the left front leg. So in this case, this is where we imported all of those things from, more like a mask of some sort. And then if you look at it, it animates currently. Most more like a game where you see all these animals in the game and they are moving and moving. This is exactly what is happening. In this case, I can turn off this. So the head doesn't animate anymore. It remains idle. It remains totally off in terms of animating it. If I put it on run, this is how the head will be when it is running. So you define all of these things. And that's why you can see that on the body, it looks like it's more of triangles, triangles, triangles. Those are vertices. This is how the head will move when it's running. You can see the individual animations that was done. This is how it will look when it's idle. Now, if I want to make it look a bit weird, I'll make it run. I'll make the tail, the legs run. You can see how the left will run. So when I turn the right and when I turn it to work, if I turn it to idle or off, you can see only the leg is moving. If I turn this off, only the left leg, which is one that is on run. If I turn this back to run, both the front right leg and the front left leg and the back right leg moves. If I turn both of them, you can see that it runs but it still looks idle. The head is still maintaining the idle animation. If I change it to run, you can see how it's now going to run it like an actual animal. If I turn it to off, it's just going to remain static. Now this feels weird. Why? But that's basically what we defined in the keyframe. So this is how it's going to look like. Like this is going to be idle, like this is going to work. So if I turn the tail, you can see the tail is also idle. If I make it run, you can see it flaps along with the animation. So it looks real now because everything is about running. And I can also turn everything off. And if I turn it off now, it seems very weird because just one of the hand is moving and then I turn this one off and it freezes.
It's 17 hours.
And so basically this is what happens here. But this is a bit tricky because if you want to understand all of this, you can see that we are loading different assets and we're adding them to the mass group part. Now, mass group part in this place is being used multiple times. Now, if you go down, you are going to see that here. We have to actually implement the animated fox first of all. The mass group part, where is it? Yeah, this is it. Create each mask group. So we create a mask group for all of them. And that's basically how it works. So the first thing will be split all the prefix and suffix, convert them into names, then add it bone in the chain to the appropriate mask group. So it's more like we take each of the pieces of the fox and we combine them together to create the animation that we see. And that's why you see that it takes a lot of code to implement this. But then it's a very good way to see the animation work. Why is this taking? What's wrong with this browser? Is it frozen? Come on. Let me close some of the ones I'm not using. So that I'm able to show you guys some of what I want to show. You've seen the atmospheric fog. You've seen this. You've seen this. You've seen the animation masks also. So yes, this is one of the ones I wanted to show us today. Another one I want us to talk about is before we proceed, because like I said, we still have a lot more things to do, but I want us to do something more hands-on today. But all of these things are just to give us an idea of what is possible. So we can see the projection zoom also. We can zoom into. Now let me show you this. The reason is because this is we want to first look at how camera movement works. Now, and I think this is more. This is even more of what I want to show. This this that's the camera orbit. So for the camera orbit, you can see as I move my screen, you can see I'm literally moving the camera. As I'm moving this, move left and right, mouse up or down. You can see this now. So how does this work? All we do is this is just basically moving the camera. That's literally what is happening here. We are moving it, but we are moving it with respect to, first of all, we understand there's a camera here. You set up a 3D scene, the camera, the plane, the cube, and the light, which is basically the four things that we are interacting with: the camera, the scene, the plane, and the light. Now, what's the difference between that one and this, the plane and the scene? The cube, rather. We have the light, the cube, the plane, and the camera. So we have the light direct, we have the plane, we have the cube, and the camera. So that's the scene that we have. So then we have the text, which we also implemented. We need to spawn that. I think that was done here too. So this is instruction. So now for the orbits, how does that work? Now we need to work with mouse positioning here. So that is important. So we need to actually not just work with cameras alone, but we need to work with mouse. So we use the button input mouse, accumulated mouse motion, which is for tracking when you move your mouse across that. And what happens here, you can see camera dot forward, camera dot this, because basically what we are doing is we are moving the camera. You can see camera dot rotation. So it means that this movement here, for us to see it in action, okay, let's look at this. Scroll wheel, wheel in to zoom in and out, space. You can see the two different projections we have. We have the orthographic, we have the perspective. Orthographic, perspective, orthographic, perspective. So you can see how we can zoom in here, see it consistently. We can zoom in, but there's a cap to how much we can zoom in and out, which is like a clamp. We already did that yesterday. Before yesterday, we saw how the clamp works, right? Where we can set a clamp, which is this, you can see, right? So we already understand this works. So we can zoom in and out slowly. It's not that smooth, but yeah, you get that's what I wanted to show us. But this gives us much more perspective. And then this is it. So this is another implementation of moving the camera, right? Yeah. So first person view model. Now let's look at this. Now this is important because if you've ever played the first person game before, you understand how it works. You are seeing the world more like the way the camera sees, but you're interacting with the world basically by looking at it like this, because it comes from your view now, not from the camera view itself. Now the view of the world comes from you. You are more like the camera in this case. Now you say move the camera with your mouse, press arrow key to increase the FOV of the view model. So this way you can see far, you can move it left, you can move it right, you can move to see the entire 360 view. Right? You can see all of this. Now this is a first person view. First person view. Let me use that word. So that is it. And this is another way you can implement this. But I want to show you something important here. When we look at the camera sensitivity, okay, we don't really need this. Let's proceed. What camera, we define a component for the world model camera first. But I want to show us the player itself being the one that is working as the field of view right now. So in this case now we spawn the player. The player is the one we spawn. But remember that the player is already defined, right? As a component. That's the way it could have been defined as a command with a command here. So we needed to have defined it as a component. So that was what we did first of all. So we define the player, we spawn the player, spawn the camera sensitivity, and we did a bit of transformation on it for the camera. Now, for the player rather. Then we maintain the visibility. Visibility also comes from where is that? Yeah, from the camera. Right. We have that also from the camera, the visibility. So we use that also, and then we get the visibility, and then we get the default visibility, which means based on what the person can see. Now, remember we set the camera sensitivity for that user too. Now, we set the children for that particular player as the world model camera, the camera 3D, and the projection. But the projection in this case now is projection from where? The perspective projection. Remember, I showed you guys just two type of projection now, orthographic and perspective. So what kind of projection does the user see? In this case, this is a perspective projection. That's what the user see. If you set it to orthographic projection, it's going to look somewhat like this. So that's basically what we defined here. So we defined that, and after defining that, it says spawn the view model camera. So after we define the children for the player as one of the camera being the children for the player, right? We also define and spawn the view model camera. In this case, we define another 3D model, and then we configure the camera, and then we define the projection for that as a perspective projection also from a particular view. Then we render the layers belonging to the view. Then we spawn the player right arm. In this case, there's no right arm, right? I'm not sure we can see any right arm here. Did we see any right arm here? No. But that's an actual implementation, right? So all games like in COD and all of those things. So we can see that there is a spawn the player's right arm, which is a 3D arm material, all of those things. Now, the arm, where does the arm come from? This is it, the mesh cuboid. So the arm is just in this case just a cuboid that was created. Okay, maybe that's why we didn't notice that that is an arm. Okay, let's assume this is the arm, this green thing you see here. Oh, there, that is the arm because it remained fixed. Oh, yeah, yeah. So this is the arm. This green thing you see here is the arm. I'm just wondering why. You can see it moves with respect to the user's view. You can see that. So it doesn't do anything different. Okay. So now you can see that if you want to build that, so all we need to do is just replace this cuboid here with an actual model, the actual model of an with probably anything you want to, maybe flowers, guns, whatever it is you want to add to it. But you get my point. It doesn't mean you should implement that. I'm just saying that for a game, that's basically what's like a game like Call of Duty has exactly. There are other games that do not have that too. So let's go to so now we've talked about most of the things I want us to see here. The first person view. Now let's go down a bit. These are like diagnostic tools and dev tools. We don't really need more of this for now until we start writing more things. Now, now the ECS now, how do you disable the entity? Demonstrate how to hide entities from the ECS without deleting them. So we can actually do it in such a way that we hide them without deleting them. We'll come back to this when we need it. We don't need them now, so we won't really do much on it. The observer propagation. Demonstrate event propagation with observers. Now let's look at an example here of it with this observer. Now, more today is more like we are doing more sightseeing before we go into the game section. Now, I know this is where it's interesting to look at because this is what we actually want to talk about more. But let's look at some of this, the observers. I hope that loads first of all so I can show us what we want to show. Is it loaded? Let's check again. Oh no, still not loaded. Oh yeah, finally it is. Now click on the mine to trigger it. When it explodes, it will trigger all overlapping mines. Now this is more like a game, so you can see. You can see this is more like a game. It's kind of relaxing if you think about it. And it's fun because yes, you can do it. You can add more challenges to it here. So it won't be just like this, but this is actually a game that you can render. And you can see this works, right? And these are these divine like gizmos, if I'm not mistaken. Okay, so I think this shows us what this is about. Our ability to hide stuff without removing them. This is another way you can do it without deleting them. You are simply just hiding them. Now let me show us where that happens here. So in this case, first thing we do is we add observers. We've not talked about observers yet, so this might be difficult to explain a bit without talking about observers. But yes, let's proceed. We are still going to come to that. Now, observers are systems that run when an event is triggered, right? The observer runs whenever exploding mind is triggered. In this case, in the case of this, so we add an observer on add mine or remove mine. So this is where we are going to or remove mine. So the observer runs whenever the mine component is removed from an entity, including despawning it and removes it from the spatial index. Remember, we spawn things initially. Now we need to, but initially, if you notice this, the first thing that happens here is when we spawn the mine, we observe it immediately for when it explodes. So observers can watch for event targeting a specific entity. We create a new observer that runs whenever the explode event is triggered. So let's say we spawn that, we spawn the observer too. Now on remove, what happens? We implement a remove on the mine. We have a query to get like results that we want for the mine. And so we query to remove the particular entity, that particular entity that we are clicking on now. So we remove that, we get that position first of all. We get all the ones that are close to it. In this case, we can see it, we get the tile, right? And then we implement the remover. So how do we do it? We get the index. The index in this case is the index of the spatial index that we define. The spatial index is coming from up here. First of all, let's look at the mine. We define the mine as position and size, right? So we can track all their movement. And then we define the mine by just creating a for loop and all of these things. And getting nearby. Get nearby is a function that is defined here to know which mine is nearby in another mine. So that way we can use it. So you can see it here, get nearby. So the spatial index is a struct, and we implemented a struct. How do we do that? We just get the nearby by calculating the tile, getting the position by the cell size, and adding one or two stuffs to it by determining, using that to determine which one is beside which and which one is not beside which. In this case, it's just a for loop that maps from -1 to 2, -1 to 2 for while loop, a nested loop, and then we extend what happens by just multiplying by the ones by the side. We can't really know because the spatial index, but yeah, that's basically what happens in this case. So and when that happens, like I said, this is where we okay, yeah, this is what I said, is a gizmo. All of them are gizmos. So we created them as gizmos and then we just give them random, we created it randomly, right? Randomized, not really randomly in this case. We created them as a loop and then we just position them randomly. Back to using the word random, right? And yeah, to remove it, we despawn them from our index. So in this case, we already understand the index is coming from the spatial index, and spatial index also is coming from somewhere. And let's look at where spatial index is coming from. First of all, we had the init here, spatial index. Spatial index. So that means spatial index exists for us already. All we did was just to implement a function on spatial index. Remember that spatial index, like I explained yesterday, is a struct, and that's why we can define an implementation on it like this, right? And that is it. So that's another thing I wanted to show us. Before we go into it, I want us to try the games today, right? It's because it's not really that difficult to do anymore, right? We might not have all the things we need to be able to build it, but like I said and I keep saying, when you need it, you will find it. It's one of those things we learn in software development generally. When you need it, you don't need to know everything at once, but the moment you need it, the moment you need a thing, you find out to do it. So there's no point dwelling on other things. We spent 3 days learning, seeing the basics. Now we can read the code. What do we need to do? Implement an actual game, right? So let's do this. So we have gizmos here, 2D gizmos, 3D gizmos, axis, and light gizmos. But we're not going to do with gizmos yet. We are simply going to go back to games. I just want to show some other things here. Okay, let's go back to games. Let's implement gaming. So the first thing I'm supposed to do is implement a game menu first of all. Now this is important because every game has menu. So two things I want us to implement these two, combine them together. We start with a loading screen. Let's start with you should open a new tab. Let's create a loading screen first of all. So I'm going to create more. I'm going to close more of this that I've already opened here. So I'm going to close the view, the camera orbit, projection zone, animation mask. Okay, so we have the loading screen. So the loading screen in this case is a way of just like for every other, every any game, any app you see, there's always a loading state. So in this case, now if I press one, it tell me loading and loads this new scene. If I press two, it loads and renders another scene entirely. You can see it's rendering the assets, rendering and loading whatever it's going to need onto the app itself. And that's why it's taking a bit more time. So do you understand? This is just a simulation to see how it works in real time. So when you see games like that, like very heavy games like playing FIFA or eFootball, all of those things, or Call of Duty, or any of these games that you play on other places, you see how long it took to load this scene because it just showed me loading because this is an actual scene that took a lot more time to load, to render. But you can see that it's rendered eventually, but it took a lot of time. So rather than me feeling that the app has broken or the app lost state already, I see the loading state. So now if I reload it now, it should load faster. It shouldn't take as long. You see it now because that's loaded it onto memory. So that's basically what is happening here. So now how do we implement a loading state? How do we do that? Now it requires us to have something we want to load first of all, right? That's the first thing. We have something we want to load. And then when we define what we want to load, then we implement that as a loading, as data that we want to load actually. So that's the next thing. So basically that is what we did here. So we have the flight helmet here. In this case, that we loaded the scene. But now the major thing is how do we add the loading data? First thing is you can see update loading data here. Loading data, rest mute, loading data. Rest that's the resource, right? Mutable resources, loading state. So we have to define a loading state and a loading data that we can always update as we work and as we implement it. So that's basically what is happening here. Then how do we display the loading screen? It's displayed differently, right? And then we can see it creates this. But now this is something we need to write to actually see it work. So actually see it work. But first of all, what I want us to start with is not the loading state. Let's start with the game menu first because this is actually simpler to implement. All we need is just to create basic shapes and text, and that's it. Of course, like I said, it's simpler. Reason because we've done a lot of the things that we should need. But looking at the state of the code is actually more. You can see it has a lot more code. Interestingly, we don't need to write everything. All we can just do is copy it. But it's more of just text and adding stuff to it, basically. Sorry. So basically, this is how it works. Sorry, just a minute. Give me a minute, guys. Right. Sorry, guys, I'm back. Um, just needed to attend to something. And it was quite urgent. So, um, all right. So, in the light of this, I might have to end this a bit earlier than planned. I'm so sorry, but maybe in the next few minutes, 15 minutes max. But then let me just show you guys what we need to do here. First of all, like I said, we don't need to write all of this. We just need to copy it and reuse it as well. So to be able to implement something like this, so what this does is this. You can see there are a lot of things happening here. This will just load and take you back to the main screen. Settings does the same thing. It opens more settings for you. Take it back, displays this, load it, take it back, and it preserves the state. You can see this. Preserves the state. And if I click on quit, the application ends. Basically. So what we are going to do is we are going to copy this. We are going to copy it and then we are going to change it. Interestingly, this is possible, 100% possible. And it shouldn't be difficult to implement. It's a lot of code, right? Like it's a very much, very, 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 very crazy amount of code in this case. So, but then we are going to do it. We are going to still implement it. So let's create something called menu. So I've got it menu. I will create it inside my source for directory, call it menu, and attach to module, and call this and paste this into this place, but we don't need this. So you can see that literally we are clocking how many lines of code? About 750 lines of code. Now this will work once. Why? Because it's an actual implementation. We can copy it and it should work for us. So we need to remove this. We need to load the menu. And make it public. Where's the main function? So we can implement this also. But you notice that we don't have some of the assets, like the icons. So we are going to have very different implementations here because we have different assets. We don't have the arrows, so we won't have it here, but it's still going to work the same way. I can make it full screen and it still works. We can go to settings, just the same way we maintain the state, and it still works. So that's more like a timer. It does that after some seconds and it goes back to the previous screen. So now let's see how this works, right? Because we want to make changes to it. We are going to make changes. We are going to update it. We're going to change some certain things here. So the first thing you notice here is that we create, like I said, the game has state. The state is maintained. So we need to create a global state for the game. And in this case, since we are working with three different things, we are working with not even three, just two, right? Or we are working with the game, the menu itself, right? And we are working with two different things within the menu. The new game, the settings, the quit is something that just closes the application. So we are working with this and this, but this is not a state. The state is actually done inside of the settings more. So because of that, now we need to maintain the first. We need to create a global state for the game first of all, taking into consideration the splash, the menu, and the game itself. So that means we have a state for the splash, for the menu, and for the game. So two things now. One of these two settings can be set through the menu. It will be a resource in the app. So we'll come back to that. We'll understand it. First thing, like I said, is we need to understand that the one that requires the state more is the settings. And most importantly, the two settings, display settings and sound settings, because their state are preserved. You can still see it still maintains the medium. If I change it to low, I come back here, it maintains the low. So that is the norm for display. So I maintain the state for the norm. I define the norm rather, the display enum. I also do the same for the volume, but this time as a struct because it's just numbers. Remember, it's just numbers. If I create the sound, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's different. So it's created as a struct. Then we need to create the main by just as usual, add some other things, add the plugins to it, add our resources. But in this case, we need to add the resource. Insert the resource, insert as resource the initial value for the game setting. Now, that means when we are adding things that should be preserved over time, we're adding them as what? As resources. So this is important because when we are working with more complex games, right? This is basically what we are trying to do. So insert as resource the initial value for the settings. We need to make it a resource. And what do we mean by that? The initial resource is going to be what? Medium. So what does this mean? If I display this as low, right? I go back here, I come back, creating a new, even though it does nothing, just reload, go back to setting, go display, it's still on low. For the time this application is alive, it will continually remain on display low. The moment I close this and I return here, what's it going to display by default as the display quality? It's going to be medium, no longer low. You can see. So that's exactly what we mean by this. Insert it as a resource. And for the volume also, looking at it, what does it mean? You can see it's at volume 7. 8 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does that mean? Insert it as volume 7. Now the reason is because starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, right? Yes. So that's basically what we are talking about here. And remember that the resource, the volume is what? Volume is a U32 size. So it's an unsigned integer. So basically mean that starting from 0, since we did specify a default for it. So that's why we have this. So just to demonstrate, we can set this to 5. If you go back to settings and check that, you should see it's on the 6th menu. 0, 1, 2, 3, 4, 5. So if I just set this to 1, you get the idea. It's going to be the same thing, right? You can see 0, 1. So that's what this means. So I'm changing back to 7. So declare the game state. Whose starting value is determined by the default trait. So we need to initialize the state for the game. And the game state is what? This, remember the struct we created, the norm we created rather. And it says define it to do what? The starting value is what? Is defined by the default state. The default state is what? The splash. So that's for the that's what. So the default value for this game state is defined by whichever carries this default state. That's what this means. So we need to now add the systems. Initially, remember we first added the plugin, added the resources, initialize the state for the game. Then we started by adding the resources, the systems rather, where we set up all the cameras and all of those things that we need, if and that we need for the games, right, to be run successfully. So we add the plugin for each of the states also. Now in this case, we add the plugin for the splash, for the menu, and for the game, and then we run the app. So if you notice here, there is no update here as we usually have. There is no update. There's just a startup and then plugins. All right, so let's look at this now. So let's start with the setup. We already understand how setup works, right? We only spawn what we need. In this case, we're only spawning the camera, nothing else. Just because it's just basic, right? Just displaying just a shape with individual buttons as a shape also. So let's look at this and proceed. So what's the next thing? We need to define our splash. Our splash is a module. We can move this out of this place and import it. It still works. That's the reason why the code is that much, is because everything is added into one. If I'm writing this like myself, right, this module will probably be in a different file, the game will be in a different file, the menu will be in a different file. We can do that, then import all of them into the menu itself, and that's how it's probably going to work. But for the sake of making it easy, because of just this scenario that we are, let's start with the splash. Let's open the modules inside the main file and see what happens first of all. So let's see the splash, and in this place we see excuse me, we see the use Bevy, right? You can see that we are importing it again. That's because the module is seen as another implementation entirely different from what we see here. So that's why I said it will be best to move it out if you're actually implementing it like an actual implementation. So after we initialize our setup, you can see the setup for the game itself. The basic setup is quite simple. We define our text color as a constant so that we can use it across board, and that's why the text color is this ash color, gray color across board. So then let's look at our splash mode, our splash, which we create as a plugin, right? Or which we add as a plugin. The first thing we do is we import Bevy again, and we use the game state from where? From super. Super means the parent in this case, or the instance where this module is being defined on. So this super gives us access to the parent, which in this case is the menu file itself, right? Because this, we doing this as a module simply means that we'll have done something like this. I will have copied the splash from here, copy this. This is what it means I will have done, right? My super game state. Then what I will have done is, instead of putting module here, I'll just do mod slash splash. Something like this is what I will have done, right? So it says it doesn't see it. Why? Because we need to create module file. We already have it as a module. The reason is because we need to create it as a module file, as a module itself inside the menu. So what I should have done is to create a directory. Let me just show you that. Basically, let me leave it since it has created it directly for us already. I should have created it directly for this by creating a menu. You can see it here. Then pass the splash into it. So this splash should be inside here. So I'll overwrite what is inside here. So if you go back there, so the reason why it's complaining is because it's defined multiple times, truly, here and here. So if you comment this out, we see we have this. You can see this, right? Now this should be fine. Doesn't complain anymore. The splash here doesn't complain anymore. So we have access to the game state now. Consider importing this in num instead. The reason why we can use it as that game is because if you are doing that, but if you are doing this, we need to use the menu. You can use create.menu here and it works fine. You can see. So this is basically how it will have worked normally. But this requires us to do many things, which we need to explain again. So for the sake of simplicity, that's why we did not do any of those things. Especially importing this, right? So that's basically what we are trying to do. So in this case, the menu is the menu, and then we splash is the splash. I can still leave the splash here without like doing anything to it. I'm not going to import it still because I don't want it to cause problems in the file. So I'm just going to close this, assume it does not exist, right? But you guys understand what I was trying to explain. So going back to the splash, we need to define the plugin, right? The plugin that will display the splash screen with Bevy logo. According to what we have here, say we need to define a screen. That's the splash screen that will define the logo. All right, so this plugin will display a splash screen with Bevy logo for 1 second before switching to the menu. Now, does it do that anytime we reload the page? The reason why it might not do that is because we don't have the Bevy splash screen, the Bevy asset, right? But then let's see what happens here. We define the splash plugin. If as this plugin is managing the splash screen, it will focus on the game state. So let's just basically see what happens here. We define the plugin by it's just a function, right? We already understand that. So we're taking the app instance as the first parameter. So in this case, our self. So we take that as self. So next thing we do is we use the app that we get here. That's an instance of the app itself. Then when entering the state, spawn everything that we need for the screen, which is what? The splash and the splash setup. So that means we still need the splash setup. And if you go down, you can see the splash setup already exists here. So that is where we have to import the asset, which I was saying that we don't have here. We don't have defined, so it will not display that on load. So when we do that, the first thing we do is the add the system here. So that means on enter of the game state.splash, show the splash screen, which is what we said. To display the Bevy logo for 1 second before switching to the menu. So what will happen? While in this state, run the countdown system. So we need to run the countdown system, but because we need to make it a countdown, we need the update scheduler so that we can run it once per frame. So the countdown now is what we need to now check. Where do we implement the countdown? What am I doing here? So what does it do? It's just a timer, right? Remember the timer.tick that we talked about? Yeah, so it's an instance of time. It checks if it is finished. And once it is finished, it sets the game state to game state.menu. Basically what happens. So now let's check that again. Let's refresh this and observe what happens. Now, remember, see that 1 second load before showing this? That was supposed to show us the Bevy icon. But before, because we don't have it, it just made it look like it's empty. Now, that thing you saw there is just the loading state that we're talking about initially. So this is a simple loading state. But this is a timer. This is just a countdown. It doesn't really work with what we are trying to load. So in this case, if you're trying to load assets, right, like an actual game where you have to load thousands of assets. Like for instance, let's say Call of Duty now. You literally need to load the world. You need to load all the assets, the game assets, in terms of like maybe the weapons that are used, or the as asset for. So you need to import all the assets to be sorting user does not visit. And that's why you see that loading time. That loading is a lot more time because it needs to read from file, read it into memory, and start processing it. So that's the difference between this. So this is just a simple, but you can see this when you run in. So count down and run if we are in the game state splash. That's when this will be executed. So the unsplash screen here is just a component also that we can use for some setup, which is what you can see here. That's why we need to now spawn what we need to spawn this. This entity will be despawned. Remember that despawn thing we did? We checked previously. Now this is what is happening here. You need to be despawned on exit. Now this entity will be despawned when exiting the state. That's the despawn on exit implementation we have. Then there's a node displays where it's going to be, that actually controls where it's going to be displayed, right? Which is what happens in terms of like the alignments, the width, the height, and all of those things. So now when you spawn that, you despawn the game.splash when the splash setup is complete. Now on splash screen now, that's when you move to the splash screen, which is what we defined as this. Then you have the children defined, which contains the image node for the icons we want to use. But remember, we don't have any of the icons, so then we don't expect them to be displayed or loaded. Now inside the timer as a resource also, the timer that we use for the splash screen as a resource. Now, I know all of this may seem like we are just reading through and we are not implementing it ourselves by taking actual logic. But the thing is, imagine if you are trying to implement this logic, and if you are familiar with Bevy, it's understandable. But if you are not familiar with Bevy, you don't even know what library to use. And that's why one of the interesting things about the library is that there's a lot of examples to show you what you need. And you cannot implement this without being familiar with it. It's literally impossible. So everything we are seeing here are, like I said, imagine what we've done for 2 days, right? We didn't create any of them ourselves from scratch, but we tweaked it to create a new thing from it. For instance, when we did the sprite animation and the sprite sheet, we started with a simple implementation that they gave to us. Then we modified it. We added transformations, we added perspective, we added a light source on our own because we understand that those things exist. If we did not go through the examples, there's no way we would have known. So it's a, it's a way of reading documentation. The reason why I'm just doing this is to help guide us and show us that okay, this is what they do. So I know that this may seem like how do I remember them? That's the beauty of it. You can always then modify it, knowing fully well that it doesn't work. Remember when we wanted to do the animation, the translation, and the rotation transformation on the shapes we implemented 2 days ago? We started with the shapes. We understand that we can define the shape. So it was easy defining the shape. We defined different shapes. We defined more shapes than we were given in the example. We implemented different color. We added the translation easily. But transformation was the rotation transformation was difficult because we didn't see it, but we knew we can implement it. So we looked at another example that implemented rotation. We picked it and we tweaked the original code that was given. Not the one where we copied from now, but the one we've written, and we added it to it, and we made modifications to the code. That is how to build software at the end of the day. You don't write everything from scratch. There's somewhere that have written something that you can use to make it work for you. So even if you're not using the person's library totally, you are picking the logic from it to use. It makes it faster for you. So the reason why we are going through this, make just feeling like we are reading everything, reading is because we need to be familiar. You need to be familiar. There's nothing you build in this world that does not first require building before execution. That is the way it works. Think of it, any physics, whether you are a physicist, you are a scientist, you are an artist, whatever you want to do, you need to first study and observe it before you start building. Whether you are an architect, you do the same thing. Engineer, you take samples, you do execution, you do simulations. That's the same thing that we are trying to do here. We don't jump into a new programming language or a new framework without understanding what it can do. If you already have an idea, yeah, fine, feel free to do that. But in this case, I'm not, like I said, this is beginner friendly. So it's going to be as if we are learning Bevy from scratch, right? And which is what we're actually doing. And based on the things we've created so far, we created 2 things yesterday. We created the scene and we modified the scene immediately while creating it. Added different light sources, added our own shadow, implemented custom configurations for it, for the world, for the backgrounds, for different things. And then when we did it today, first thing we needed to do was to add a plane, a 3D plane. But because our camera configuration is different, it didn't appear like the example. We modified it. and we made it out fit into our own workflow. So the same thing is happening here. We are creating this game settings menu because we know we can do it. If we want to modify it, we can also modify it. All we need to do is we modify it, we configure it to what we want to do. So by the time we implement our own game, we need the menu too. What we can do then is copy it, tweak it, add this here, change this here, and everything works fine. Perfect. We are done. That's perfectly how we are going to implement it. But we need to be familiar with how the menu works. We don't want to think of it and rack our head again to be implementing, okay, what's this and this? But we know that we don't need this, we can remove it. We need this here, we can move it here, we can add this here, we can add more options. That's basically how it works. Now, basically, this is just two different options: menu, the new game, and the settings. And the only one that works is even the settings. Now, imagine if this is an actual game, we can want to have more menus, right? Or let's say we just have these three menus, but in the settings, we want to have more than just display and sound. We want to have other things. Or in display, we want to have other things aside from quality. We want to have other states like the view size, the frame per second, all of those things. We can configure all of those things too. And now, based on what we've learned so far, we can configure our frames per second for whatever we implement because we used it yesterday. From implementing one single frame per second for our sprite, we implemented two different sprites, gave them two different frames per second, modified the way they display and all of those things. And we used it, and it made a lot more sense. And that's the same thing we are working with today. And that's the same thing we are doing today. So in this case, it might not make sense, but yes, this is actually fine for our use case. So I understand this may feel more repetitive every day, yeah, but it's necessary and it's needed. So now let's proceed with this. So yeah, we insert our timer as a resource. And we remember this timer mode once yesterday, which we used to change our animation sprite from running once to running repeatedly. Exactly. So so that's the same thing. In this case, we are running the timer, right? To be sure that our splash screen setup is handled properly. We need a timer to be able to check the updates when it starts, when it finishes. So in this case, tick the timer and change the state when finished. So that's what tick does, just like the tick of a wall clock. That's basically what it does. Or a tick of any clock, whether a wall clock, a wristwatch, all of those things. So this is what that does. Now, in this case, we've seen the splash. Let's look at the game. You see that we have to import it again, and then we need to use the super, get the game state, the display state, the volume, the text color, the display quality, because we already defined them out here. So we are now using them here. So that's what we did. So in this case, the plugin will contain the game. In this case, it should just be a screen that will display the current settings for 5 seconds before returning to the menu. So when we click the new game, in this case, which is just the game, that's what happens currently, right? We click the new game and it goes here, and after 5 seconds, it comes back. How do we implement the 5 second logic? Remember the tick. We need to use that also. So, but yeah, this is how it is done. We create a game plugin. We add on enter the game state.game, implement the game setup. So add systems update, because remember we are trying to now check, we are trying to watch basically for when an event happens. So we need to update. We need the update scheduler to be able to do that. Then we check the game and we run the game state. If we are in the game state.game, that's only when this is going to run. I don't know if that makes sense. We used that already up there, so it's basically the same thing. So tag the component used to tag entities added on the game screen. So we need to go to the game setup. And what does that do? We take the command display quality and the volume, and we despawn on exit. Now in this case, we use the game state game. We create our load to configure how it's going to work. But first of all, we first despawn the game. Once it is done, that's where the game setup comes in here. So when you enter the system, you first check on enter of the game state.game, you run the game setup, and the game setup does one thing. It despawn the game state.game first of all. Remember this thing we learned here about observers, adding to screen, removing to screen? No, that was not it. observers basically, where you can add to screen, remove from screen. That's exactly the same thing. So you can see how all the knowledge builds on one another. So we despawn here to be able to remove it from the view totally. And that is what is happening here. So when I create this game, you can see what is happening is we are despawning that one. We are spawning this view. This view will be back shortly. We are basically spawning it. So yeah, we'll see where that happens now. You can see that the first thing we did is we despawned the game state, right? Now we created the configuration for the new thing that is going to be displayed. Then on the game screen, which is the component we already defined, we define the children that will run also on this same spawn, right? In the same spawn instance. And we created the node for how it's going to look like. We first added the column flex and then we align it to the center, which is what this text is all about. You can see. So we added the color to it to black. You can see that's the color of black. That's where this is coming from. We added a black color to it. After adding a black color, we added a child again, another children set to the node. Because remember, this is a black color. It has three children. This text, this text, this text. Now let's see what happens. We'll be back to the menu shortly. Is the first child of that, which is this. The second child will be quality medium, right? You will see this. You can see the first child here is what? This text color. We define the text color, which is the gray color up there, and that's why you see that if you define, you see it's gray color. This is blue and this is green. Let's go back and check that. So remember this styling is what? Align center. So we align to the center, and that is why we have this here, right? So now we have the background color defined. Then we have the children, which is the we'll be back shortly. The second child, which is what? Quality of something. But you can see how we define the node here. We define the margin with it by setting the margin to be 50. And if you click on it, you can see the margin 50. So literally that's what will happen. And then the font size is 50. It's smaller than the original font size of this one, but it's still big enough, 50. Then text color is blue. Basically, blue. So where did we get blue from? We imported it from the basic palette, blue line. And these are the two colors we used. So we use blue, right? We did the same thing for what? The volume. But remember, we are getting the volume and display quality somewhere. So this is display quality. It's coming from here. So on game setup, you get the display quality as a resource. So that means all the property of that and the state also we get, and the values rather, we get that from display quality. And that's why we're able to access it. But what we did here is by getting value, then we are setting it here, basically. So we are getting not by reference, not reference now, we are getting the value itself. We are not getting a reference to it. We are getting the actual value and passing it here. So the text font is this, the text font, all of those things. So here we insert the resource again. So it says spawn a 5-second timer to trigger going back to the menu, and that is where this happens. Remember, I said we need to use the timer once again for all of those actions. That has to do with timing, that has to do with movement, that has to do with sleeping or display or changing states based on a certain number of time. We need time to make that work, just like in the real world. You calculate 5 seconds before you do something. You are working with time. Same thing happens in this game world. So what happens here is we use a game timer, create a timer, then from second we create 5 seconds, then timer mode is once. So we are simply saying that insert the resource. What resource are we inserting? This game timer, right? And so what does that do? It checks the timer from second 5, check that it runs once, and once it runs successfully, it goes back to the original thing, which is we despawn the game at first. We show this all of these children, the game screen. Then once we are done again, we do this. We insert the resources. We run 5 seconds before going back to the menu. So now tick the timer and change state when finished. So what does that mean? When we are done, which is game here, let's look at where we use game here. Remember here, game. When we added the systems here, we did two things. The on enter is what we run the game setup. On updates will be running on every render. So that is why when we did this and we did it up to this point, we're only checking the 5 seconds because it's going to be rendering of every frame. This one is going to be listening as the update is going to be listening if the 5 seconds is over. Once the 5 seconds is over, it's going to run the game. If the game state is what is game. So it's going to run the game again, and that's why the game here tick the timer and change the state when finished. So that's why we use the timer. So when the timer elapses and the timing is finished, which is this time that we set from here is finished here, it will set the game state back to what? To menu. Remember we unspawn that particular or despawn the game on exit first of all. Then the next thing we do is we set it back to menu. That is why after 5 seconds, when we click this, it goes here. After 5 seconds, it goes back to menu. Why? Because it automatically knows that it is sticking for when that event complete. And once the event completes, it's going to set it back to menu automatically. We are trying to implement here with the game. I think that's the which is the menu. Now, in this case, it's the definition and the definition of things because all of these are the menu. So we this plugin. So you say there's many plugin which manages the menu with 5 different screens. With 5 different screens. This screen, which goes back after 5 seconds. Right. This is screen one. There's another screen which is this. Right. There's another one which is this. We go back 4, and then that is it. So we have the first screen, this screen here, this screen, which you go back, the setting screen, 1, 2, 3, and we come back. So that means it manages the 5 states. So this is another thing. So that's the fifth screen. So this is one screen. New game gives us another screen. Settings page gives us another screen. That's 3. Display, that's 4. Sound, and that's 5. And that's it. Those are the 5 screens we are managing. Right. So the menu plugin defines the initializes the state, just like we had before. Add the systems to it. Add the menu system, the main menu system, the setting menu system, a setup rather. And we already have the setup. We already do have the setup, but this one is particular to this module. As you can see here, it creates that particular node of calling it what 200 pixels in width, 65 in height, and define the text for it. And what's the text that I defined for it? Yes, new game, right? Let's check it and see. Display sound and button for the other one. Remember this display, adding this to children. You are spawning the settings page. In this case, this for the settings menu. So for the settings menu is going to um display sound and back, right? Display sound and back. That's basically what is done. So we are spawning this menu back button action. That's this that we have here. So let's go back
It's
to this.
18 hours.
So that's basically what we are doing here. So we are spawning this and we have to use it. So does this make sense to an extent? Yes. So this is basically what is done. So I hope this makes a lot more sense, guys. So sorry we won't be able to do much today regarding this. Like I said the other time, I need to attend to something that came up, and so that means I won't be able to continue like explaining or implementing this. I really wanted us to dwell on this, make some tweaks to this, and implement more stuff, but we won't be able to do that today. So please pardon this. I'm going to be ending this live session now, and hopefully be able to cover up for it tomorrow. I really I'm sorry for this happening today, but then I will try to make sure that we can cover up for all of this time lost tomorrow. We are going to implement this tomorrow. We are going to complete this. We are going to add a menu, and we are going to implement a menu and add. We are going to implement a game, right? An actual one, different from this tomorrow. Pick any of this game. It doesn't need to be. It doesn't need to be something crazy. In fact, it can be this game that we implement, right? So whenever we click the new game, it's going to load this. So when we are done with it, we can always cancel it. When you click settings, it's going to show this. We are going to implement that in the space of this before we can successfully say that yes, we are done with this series, we are going to implement that. So if not today, we should be able to do that tomorrow, whereby we implement a menu to any of this, whether this, or this. I'm going to, because this looks like a game to me too. So we are going to make that work. So thank you so much, guys, for joining today. I appreciate you guys joining. Please remember to share with your friends for those that may be willing to learn something like this also. Remember to share with them, and also appreciate you guys liking the video so far. And for those that have subscribed, thank you so much for subscribing. And those that have not, hope you subscribe soon as well. So yeah, thank you so much for joining today's build together series. Hope to see you guys soon. Catch you guys in the next one. Bye for now.